All right, I want to talk quickly about page 358 in your packet, converting between degrees and radians to degrees. Okay, real quick, let's just recap where we were with the unit circle. Okay, when you've got a circle, we said we can count around the circle in degrees. We always start with 0 degrees at the positive x-axis, and you count counterclockwise. So this would be 90 degrees. It's the same 90 degrees that makes a right angle. Go another 90, you're at 180 degrees. Another 90, you're at 270 degrees. And another 90, you're back at 360 degrees. One full cycle, and you're back where you started. Okay. Now, when we talk about radians, radians are really just radius lengths. So think about a circle with a radius of 1 unit, and we talk about the length of the arc all the way around the circle, almost like the perimeter of the circle. Okay. So if your radius is 1 unit, the circumference of a circle, hopefully you remember, is 2 pi times r. So if the radius is 1, your circumference is 2 pi times 1, or just 2 pi. So that's why we say if it's a unit circle, radius of 1 unit, the length around the circle would be 2 pi units. Okay? 2 pi, now remember that pi is a number. What that means, pi is about 3.14, so 2 pi is about 6.28. It'd be about 6.28 units around this circle. And by units, those are radius lengths. So it'd be about 6.2, just over 6 of these that would go around the circle and get you back all the way around the circle. Okay. So when we go around the circle in radians, instead of counting with 0 degrees here, it's 0 radians here. And we know to get all the way around the circle, the length all the way around, we just said was 2 pi, or 6.28 radians, or radius lengths. Which means to get halfway around the circle would be 1 pi. Okay, so you could count around the circle. Always start at the positive x-axis at 1 comma 0. Start there, and you count counterclockwise. So you go 1 pi, 2 pi. Every time you go halfway around the circle, that's 1 pi radius lengths. It's basically the radius of the circle. It's about 3.14 of those to get to here. Okay, 6.28 of them to get all the way around. Okay, so halfway around the circle is 1 pi, which means when you get here, you're halfway to pi. So that's 1/2 of pi, or pi over 2. So if we counted each time we go a quarter of the way around the circle, that's 1 pi over 2. This would be 2 pi over 2. 2 pi over 2, which does in fact reduce to pi. 3 pi over 2 and 4 pi over 2. This would be 4 pi over 2, which it works because that's 2 pi. Okay, so counting around the circle this way, you could also, if you want, divide pi into 4 equal parts. So that would be 1/4 of the way to pi, or pi over 4. This would be 2 pi over 4. This would be 3 pi over 4. You can think of that 3/4 of the way to pi, and then 4 pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. You can do the same thing on the bottom, because the bottom half of the circle is pi again. You can divide that into 4 equal parts. So we left off, 4 pi over 4? This would be 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So basically what we're doing is we're converting between degrees and radians. Pi over 2 radians would be the same as 90 degrees. If we got halfway to 90 degrees, well, we know that's 45 degrees. So 45 degrees converts to pi over 4. Okay, so let's try some of these. And when we talk about conversions, we're simply converting something that's in degrees into radians and something that's in radians to degrees, just like you've always done conversions. Think about back in science class, probably in grade school, you might be given something like 7 centimeters. And if you have to convert 7 centimeters to inches, well, you need the conversion factor. How many centimeters are there in an inch? Well, there are about, 2.54 centimeters in 1 inch. So that's your conversion. Okay, so if you have 7 centimeters, you multiply by some kind of a conversion. you're going to put the centimeters on the bottom, because here you have centimeters on the top. You want those to cancel. You're going to put inches on the top. 1 inch is 2.54 centimeters. So if you take 7 centimeters and you want to convert to inches, you're going to multiply by the conversion factor 1 over 2.54, putting the inches on the top because that's what you want. Centimeters will cancel. And when you multiply this out, you're going to get about 2.76 inches. Okay. Same way, if you're taking something that's in inches and you want to convert to centimeters, you would take something, let's say you want 13 inches and you want to convert to centimeters. Well, you're not going to multiply by inches on the top. Now you're going to put the inches on the bottom and centimeters on the top. And there's 1 inch in about 2.54 centimeters. And if you multiply that out, you're going to get 33.02 centimeters. So really, that's all we're doing is a simple conversion. Okay. But our conversion factor here, instead of being this, well, we know 380 degrees, 360 degrees is equal to 2 pi radians. So your conversion factor is equal either 360 over 2 pi, which let's simplify that. Just because they're both even numbers, we can divide by 2, and we've got 180 degrees over pi radians. There's our conversion factor, 180 over pi. Or if we're converting from, that's if we're converting from radians to degrees. If we want degrees to radians, our conversion factor would be pi over 180. And we can see that visually in our circle. Halfway around the circle is 180 degrees. Halfway around the circle is 1 pi. So those mean the same thing to get you to the same place on the circle. Okay, so let's just do a couple examples. Convert following angle measures from degrees to radians. Degrees to radians, you're multiplying by this. Because you want radians, you put the pi radians on the top. So we've got 120 degrees. I'm going to multiply by pi radians over 180 degrees. And you get 120 pi over 180, which reduces, those both divide by 60, to pi over 3. Okay. And looking at this, just to visualize that, that's 2/3 of the way to pi. 2/3 of the way to 180, which would get you about, let's see, this would be about 1/3, 2/3, somewhere around here, which makes sense because that would be about 120 degrees. Okay. Next one, 4180. Again, we're going degrees to radians, so we're going to multiply by pi over 180. You get 4180 pi over 180, and you can reduce that fraction. That reduces to 209 pi over 9, and that's going to be in radians. Okay. Now 315 degrees, multiply. We're converting to radians again, pi over 180. So you get 315 pi over 180. Oops, can't see that very well. And that reduces to, they both divide by, what, 45? Yeah, that's 4 45s, and that's 7 45. 7 pi over 4. Okay. This one we can look at in our drawing. 7 pi over 4 is right here. So this angle to get from here to here is 7 pi over 4. And it would also be what we're converting, 315 degrees, which makes sense. That's 315 degrees. Remember, 360 degrees is all the way around. Okay, so we're 45 degrees short of a full circle. Okay. Now, just a couple examples, converting from radians to degrees. So now we want degrees, so we're going to multiply, put the 180 degrees on the top. We're going to put the pi radians on the bottom. Okay, you can cancel the pi's. Pi over pi is equal to 1. 6 and 180 we can reduce. That's a 1. 180 divided by 6 would be 30. And that gives us 5 times 30 is 150 degrees, which makes sense. 150 degrees, that's about 5/6 of the way to pi. 5/6 of the way to over here to pi. Okay. Negative 3 pi multiplied by 180 over pi. Pi's cancel. You get 3 times 180, so that's going to be negative 540 degrees. The last one, pi over 2. Well, this one we can look at in our circle. Pi over 2 gets you to here. That should be 90 degrees. Do the conversion, 180 divided by pi. You want to convert 2 degrees, so you're going to put the 180 degrees on the top. Okay, the pi's cancel. You get 180 divided by 2, which is in fact 90 degrees. All right. Thank you for watching. Hope that was helpful. Oops.